Welcome back. I hope this video finds you well. We are talking about section 8.4 today. I've had a few questions on the board. So let's get started with those. The first one I had a question on was number 1. Somebody said I just need help getting started in this section. So let's take a look at number 1. It says it's parametric equation. And it says that x of t is equal to 3t. And y of t is equal to t minus 1. Okay. So I have these two things, two functions essentially. X is determined by, it's a function of t. It's given by 3t. Y of t is another function of t. It's essentially t minus 1. Let me see if I can change the lighting a little bit here. That probably looks worse. I don't know. Is that better? I don't know. Let me know if that's better. It looks better to me, so I'm going to run with it. Well, I'm not convinced. I don't know. Let me get rid of it. I think that looks better. Okay. So I've got x of t, y of t, and essentially I want to get rid of the t, right? And the easiest way to do that is to solve one of the equations or the other for a t, and I'm probably going to pick out the easiest t, which is this guy right here. I can isolate this t by simply adding 1, and I'm going to kind of, instead of y of t and x of t, I'm just going to write these as x's and y's, because it's easier to deal with them as just x and y. So this then, if I add 1 to both sides, I'm going to write this y of t as just y plus 1 is equal to t. But I have an equivalence now for t. T is equal to y plus 1. That means that I can take this y plus 1 and replace the t in the other equation. Right? So this x of t, again, I'm just going to write this as just x. And we know it's a function of t, but I'm just going to write it as x. But that's equal to 3t, but instead of t, I'm writing y plus 1. Okay. And this is my equation in rectangular coordinates. I'm not quite done because the solution has everything solved for y. So I would start here by probably dividing everything by 3. That gives me x over 3 is equal to y plus 1. And if I subtract 1 from both sides, I have isolated my y. On the left-hand side, I have x over 3. That's the same thing as 1 over 3 times x minus that 1, and that's my equation. The y can be on the left or the right. It doesn't matter. You'll find that the equation solution looks like that. Y equals 1/3 x minus 1. And that's number 1. The next one is number 3. Number 3 is another similar type of a problem. It's x of t is equal to cosine squared of t, and y of t is equal to sine squared of t. Right? So I have these guys, and there's no nice, easy way of solving one of these or the other for t, right? They're both stuck in a trig function that's also stuck under a square. But I can note that I know what cosine plus sine squared plus sine squared is. And so that is to say, if I took x and added it to y, that would be taking cosine squared of t and adding it to sine squared of t. But I know that cosine squared of t plus sine squared of t is a Pythagorean identity. That is 1. And so that is to say that I have x plus y equals 1. And I have an equation. Subtract x from both sides, and you have the solution that the homework site is looking for. I end up with y equals negative x plus 1, and that should be the solution. Okay. The next one I had a question on was number 5. Number 5 says to take x of t as the square root of t, and y of t is t to the 3/2. Right? And we're supposed to kind of manipulate these guys into a rectangular coordinate by eliminating t. Again, it's hard to solve for a t here, right? I could square, the top here, I could square x of t equals t. If x of t is equal to t, I can write that as simply x equals square root of t. And if I square both of those, I get x squared is equal to t. And I can take this t now and plug it into here, so I have x squared. That's replacing my t here, so I have then y equals, instead of t, it's x squared to the 3/2. With x squared to the 3/2, you multiply those, that's going to end up being y equals x to the 3rd. And that's that one. The next one I had was actually number 10, which is a continuation of this problem. It asks you to graph it. And in order to graph this, we have to be mindful of the limitations on our functions from the beginning. X of t being the square root of t means that x can only be positive or 0. It can never be a negative number, right? Because of the domain of the square root of x. So no matter what happens, x has to be positive. So if I note that, x, it has to be greater than or equal to 0. It could be 0 itself. But that's my limitation here, right? So noting that, 8.4 number 10 asks us to graph this thing. And so if I graph it, I'm graphing y equals x to the 3rd, given the limitation that x can only be 0 or more, right? And so I should know what x to the 3rd looks like. X to the 3rd would look like this. Comes from the bottom left, does that little loop-de-loop, I don't know, not a loop-de-loop, but a little saddle right here, and then goes up, right? But I'm only interested in these values where x is greater than or equal to 0. That's this right here. And it's not this. So I'm just going to erase it. It's gone. It's not part of this. So it's just that little part of it right there. So one of the solutions should look like an x to the 3rd where the left half has been erased because it's not valid there. And it's just that parabola-esque looking thing there. So that's all the questions that I had asked on the discussion boards. Hopefully this will get you through. Again, use those discussion boards, post questions. I want to say my morning class is using it quite a bit. My afternoon class is using it a little bit, not great, but post questions on there, talk to each other, get used to writing stuff in there. You can write stuff in math on those boards. So get in there, post stuff. And again, hope this found you well. Hope everything is good in your world. I'm up here in Utah. It's snowing today. It's crazy. But I love it. That's my weather. So anyway, we will see you next time, or I will catch you on the discussion boards.